Hello, and so we have another AIME problem. So this was number 14. So we have a triangle ABC such that B and C are congruent angles, and point P and Q are lying on the side AC and AB respectively, so that AP, PQ, QB, and BC are equal. And then we want to find the ACB, angle ACB, that is R times as large as the APQ. And we're going to find the value of R, and multiply that by 1,000 and then to floor it. Okay, so, okay, it's kind of complicated without really having figures. So it's a geometry. So let's start with a figure. So, and then also like angle B and C is congruent. So I'll just try to make this as a triangle. Okay, so let's say this is the case, right? So this is A, and this is B, and this is C. And like we have four segments are equal. So AP, and then P lies on AC, right? And so P is somewhere right here, and then PQ, Q is on AB, and then BC. So after B having like Q on these segments, so from P to that Q and then Q to B, as well as BC. So which means this BC should be a bit smaller than how I draw it actually, but it's fine, I guess. So I'll just make maybe this is P, and since PQ and QB will be same, so let's say this is our Q, and then this is B, and then this is C. Okay, so based on this is what we have. So we are going to connect this, and like this segment AP is the same as a QP, that is QB and BC. Okay, so we have to use these guys somehow. And the angle ACB, which is one of those congruent angles, is R times as large as APQ. So the angle right here. Okay, so let's see what we can do, like APQ, so APQ. So I'll just label the angles first. Let's go ahead and maybe start with, since like a lot of like equal like sides are given, maybe we should have somehow extra angle useful. But to chase the angles, I'm gonna make actually another triangle here, because if I start with the angle labeling right here, so that will be determined, and then we can tell this exactly how some of these two. So that will be a bit easier to make stuff visible in terms of each other. So I'll just say this is alpha, and this is gonna be alpha as well. So since those two angles are interior, if you add those two, you get the exterior, which is 2 alpha here. And since this is also isosceles, so that means this is also 2 alpha. Okay, so now we have at least some of the angles are written in terms of one thing, which is progress. And we just want to know something about angle C as well. So I don't know about this one yet. So which is what I'll label this is beta. So which means this angle right here should be alpha plus beta. So far, some progress. And we want to relate these sides with the angles. This is a job for law of sine. So if you're relating like the sides and the angles, law of cosine might be useful, but you don't really have any like concrete sides, so which might not be the good idea to try. But law of sines might be the good idea. So, but where to use it? So we just do not really have much stuff. But at the same time, remember we are told B and C are congruent, so which means AB and AC are actually congruent as well. So the AB and AC is also congruent. And I do know QB and AP is the same, which will force AQ, and PC will be the same as well. So which might be useful. So the AQ and PC has to be equal to each other. And like if there's a way to relate this like congruent segments into AQ, then we can maybe find the lost sign. But for now, we don't really have much information. But let's add the angles. Like we have 2 alpha right here, right? And then we have alpha plus beta, and then we have alpha plus beta in ABC. So which is going to be 2 alpha plus 2 beta. So if I add these guys, so you got 4 alpha and 2 beta, which is 2 alpha plus beta is 90 degrees. Or you can just keep as it is. But this is good. Maybe I should keep it that way, but that might be useful. So if you look at the figure, if there is a way to see 2 alpha and beta as one like angles of one triangle, you can find the right angle, but it doesn't look like we have. But we have 2 alpha, which is like 4 alpha, so that is just this. And then the remaining one, 2 beta, which means this has to be the case. But you know, we have isosceles triangle. We can actually drop the altitude for this guy, so we can split that to beta as well, which will be beta and beta. The reason why I'm doing this because that will make a relation between AP and AQ. So I'll say this is H. So if I use like, if I want to write AQ in terms of AP, so then I can write every side of the ABC in terms of that variable. So let's call this is X. So to relate this side to the hypotenuse, I can use the sine of the angle beta, which is going to give us like some good relation with the sine. So which is because we need to use law of sine. That is what I was planning anyway. So if I take the sine beta, right, so that will be equal to AH, like over X. So for that one, that will be AH, will be X times sine beta. Okay, so we got this guy. So AH is this, but you know this is isosceles, so that means AQ, which we already know that's also same as PC, has to be twice as much of this guy, so that should be 2x times the sine beta. Okay, so now we have this segment as 2x times sine beta as well. Okay, so now I'll just write the law sign. So I can use the, you know, this guy was X, so cube P is X, and then QV is X, and BC is also X. And I don't know this angle, but that's already known. 2 alpha is interior, so which means this angle will be 3 alpha, right? So now I can just say the side divided by sine value of that, so log sine. So the X over sine of 3 alpha. And I don't want to use this one because I have no information about this side, but I know this side, so which is opposite the angle beta. So 2x times the sine beta over the sine beta, right? Okay, so now like you can just like swap this fraction. Some people like writing the sign first and the side after, so you can flip these fractions, which is the same thing. So we actually easily cancel these numbers. We cancel these guys. So you got 3 times like sine 3 alpha times 2 equals 1. So from there, so you can say sine 3 alpha will be equal to 1 over 2. Like, you know, if you are like aware of the sine 3 like 3x like or 3 data trig identity, you can expand this in terms of sine, and then you can solve that equation. But you don't really want to try that, but still this is one of the things that we need to know, especially for the AIME level, even AMC 12 level problems. So it's good to know the expansion for sine 3 data anyway. But in our case, you know, the alpha 3 alpha is one of the angles in a triangle, which is going to be less than 180 degrees. So for sure, right? And if that's the case, we actually can like say the sine value of something is 1/2, which might be like if you like solve this equation, so 3 alpha should be like 30 degrees plus 180 times any multiple of that one. So which is gonna be not needed because we like 360 more than 30 degrees or just 30 degrees, right? So if I want to write 2k pi or 360 times k. So this is how you solve it. But you know, if the k is 1, that will make alpha is around like 120 plus 10, which is 130. If you multiply this by 3, so which will make a huge number. So which is why we cannot really have anything that one. So the alpha should be just 10 degrees based on the this equation. So we don't need to use this identity anyway. So alpha is 30 degrees, and I can plug into this guy. So that's going to be, I mean, alpha is 10 degrees. That will be beta is 70. And what we were looking for, the R was, the ACB is R times as large as APQ. ACB is alpha plus beta, which is going to be 10 plus 70 over APQ. So the APQ, which is 2 beta, which is going to be 2 times 70. And if I simplify, that will be 80 over 140, cancel the zeros. So you got 8 over 14, so which is 4 over 7. So this is the R. I need to multiply this by 1,000 and take the floor. And I think that's not going to be a huge deal. So if you do so, you will get 571. And that is my answer. So I hope that was clear. So we have like law sign useful in this problem. So there is another solution without really using any tricks. So you can take a look at and see if you can figure out. The reason why I just remind that, because I remember one of the math counts problem that I actually had a while ago was really similar to this one. And then this problem has another solution that you can actually use with that math counts like approach, I will say. So you can try that as well. But anyway, so that was AIME, so I used trick.